Alrighty, so we are back. It is day 24, and we are still in the loop of recursion for some reason. Uh, so we have that Tower of Hanoi problem still remaining. Uh, Let me just try to decode it a bit, although I'm not really sure if I'll be able to because because I don't know, man. It's just okay. Let me come in my problem solving approach position. Okay, that seems fine. Uh, Maybe I'll also start with divide and conquer just after this. Although it would be. Okay, let's see. Merge sort, quick sort, first case in quick sort, sorted, rotated, array search. Okay, so we have a bunch of stuff in divide and conquer, and then we would have the questions for that. By the way, I have submitted the project finally, and although still the work is not done, I'll have to learn a bit more Vue and stuff to answer the questions in Viva and all. So yeah, I will still be studying Vue, but at least I won't have the fucking what it's called, dude. Burden. Yes, burden on my head to submit it and get done with it. By the way, also the business data management project, and you'd only know about that if you watched my first or second video, I guess. So yeah, if you know that, you are an OG already. So yeah, that project, my proposal got accepted, and so yeah, I'll have to make the midterm report for that now, and for that I'll have to go to that shop, which is my relative shop, which is in another city. So I'll have to go to that city to uh, record a video with them and like take some pictures and get a letter that yeah, we are giving him data or whatever. So yeah, basically the proof of originality, right? So I'll have to go there. I'm not sure how will I manage to keep the streak going when I'm there, because I'll be there for like 1.5 day almost, I guess. Yeah. So yeah, let's see what can we do. It will be just a matter of one day, right? Though maybe I'll bring the camera, and well, I can't bring the mic honestly, but yeah, we'll see what can be done. But anyways, let's not worry about that. So from tomorrow, I'll what? I will start revising finally DSA, and I'll also be doing Vue. And now, by the way, I'll also be starting with ML. So I'm not really sure if I'll include that here in the stream, because I'll be learning from lectures. So yeah, let's see. Maybe I'll do the view thing on stream, because that's from a Udemy course, and maybe I can just play the lectures here, and that will be in English, so anyone can understand. Because otherwise, these lectures for DSA and for ML as well, it's in Hindi. So even if I play the track, uh, my audio track from whatever is playing on my laptop, doesn't make any sense, because most people would not understand it. So yeah, anyways, let's see what this Tower of Hanoi is like. Should I show you this screen though? Maybe I think I should. Yeah. Okay, so that's a lot of tabs, but just bear with me. So this is the question, Tower of Hanoi. It's important, and this is the thing for it. Let me make sure I'm audible and the screen. Yeah, I think it is visible. Okay. So what do we have? We have three towers and n discs of different size which can slide onto any tower. The puzzle starts with discs sorted in ascending order of size from top to bottom. Each disc sits on top of an even larger one. So the following constraints: one disc can be moved at a time. A disc is slid off the top of the one tower onto another tower, and a disc cannot be placed on top of a smaller disc. It cannot be like there is a bigger disc here and then there is a smaller disc here. It should be the this ascending order, whatever. So yeah, using stacks they have mentioned though. Okay. Uh, let rod 1 is equal to A, rod 2 is equal to B, and rod 3 is equal to C. Example with two discs. So, okay, this is example for three disc, I guess. So shift first disc from A to B, and shift second disc from A to C, and then shift the first disc from B to C. So that will move everything from A to C. Now there are three discs, so n is equal to 3. Then shift the first disk from A to C. Then second disk from A to B, and first disk from C to B. Then shift third disk from A to C, B to A, B to C, A to C. Okay. Let's see in the diagram here. So this is how it is, and source, helper, destination. So C is our destination always, I think so, and B is our helper tower. So let's say we are moving third onto the C, and then we are moving second onto B. So that's how it is 1, 2, 3. Now we are moving third to B, so it becomes like this. And then finally 1 reaches the last one. So this is empty. We can move third again here. So this can go there now, and then finally this can go there. So approach here is shift n minus 1 disks from A to B using C. Shift the last disk from A to C, and shift n minus 1 disk from B to C using A. Okay, so let's break this down. N minus 1 disk from A to B using C. So what we have done, we have used C, and then we have shifted n minus 1, which is basically 3 minus 1 means 2 disks. So we move third one here, then second one here, and then third one again here. So with the help of C, we have moved n minus 1, which is 2 disks, to the B tower. And now what we have is shift the last disk, which is remaining, from A to C. So that is done. And then again 3 steps, which will be using A, shift n minus 1 disks from B to C. So yeah, then we can move this to here, this here, and this here. Alright. So now that was just a problem, as you can see. Now we have to figure out a recursive way, I guess, to solve this. And again, I'm gonna be honest with you, there is nothing that is coming to my mind for now. And I've also realized that doing these questions, it does not help if I'm doing it in the night. So most probably the schedule I'm going to follow is that I'll be studying DSA in the morning, and then I'll do whatever other thing which need to like require me to constantly doing something. So that I'll do in the afternoon, because I've noticed one thing, right? After having lunch, if I'm having to listen to someone, and if I'm having to listen to a lecture in particular, and I'm not doing much things, I tend to feel sleepy a lot. So most probably I'll do like development practice for React or that kind of stuff. And if I'm doing that, I'll totally record that in the afternoon. But if I'm doing a DSA problem, or if I'm covering the lectures of DSA, that has to be in the morning. It cannot be either in afternoon or in night, because I've tried both, and it does not work. So yeah. Anyways, enough of me yapping again. Let us make sure this, yeah, Visual Studio Code is showing up. So let us directly jump onto the solution and try to understand it. Where is it? Where is it? Where is it? Okay. Oh, by the way, yeah, it was also discussed in YouTube video, right? I think I never opened that. Okay, so there is one YouTube video on on YouTube, obviously, uh, of the same instructor that I studied ESA from. So I think I should cover that. Okay, okay, yeah. So yeah, I think let me not jump right into the code first. Uh, let me watch this explanation and all first. Mm, okay. The thing with YouTube, right? It's just DSA, DSA patterns, DSA this, DSA that. Okay, so let me get out of that. And so as we saw, it's the A is our source, uh, C is our destination, and B is our helper. So yeah. So again, as I've mentioned before, these things take uh, yeah, these things take a trial and error kind of thing, because you have to start thinking like what will happen in n is equal to 1, what are steps being done here, and then what is basically what is happening recursively if you go on and on about it. So yeah, that's the thing. And when I'm like doing this while I'm recording, it's kind of hard to do that. But anyways, let's not yap. Let us focus. Okay, so basically it's saying that uh, what if we had a scenario like where we have the middle tower, which is helper tower. It had second and third number disk, and the n is equal to 3 case, and the first one to the destination. So that will be like moving two disks to the destination if we ignore the one disk that is already there, because obviously that's the last one and it is in place where it needs to be. So the middle one has 2 and 3 number disk, and that's basically exactly like the n is equal to 2 case. So if we get that situation where our destination has the first number disk, which was the largest one, and 3, then then it will just simply become the problem as n is equal to 2 disks. So I think you can see how it is going into recursion. So yeah, it's like 3 step, then 1 step, and then 3 steps again. So in first 3 steps, we have second and third number disk, which we have on the first tower, ignoring the first one that's below everything. So we have to transfer that to our helper middle tower using the destination tower. So we are exchanging that in terminologies. That does not matter really though. What matters is that what we have to do. So yeah, so 3 steps for that. Then just simply 1 step for moving that last disk from source to destination, and then again we have second and third in the middle tower. So from that we have 3 steps again to move that to the last one. Yeah, so in general terminologies it would be like we have n disks on source tower. So after that our first step would be to deliver n minus disk to helper, so that only one remains, which is the largest one in the source. Then we can move that to destination, and then again n minus 1 disk from helper to destination. So let us start coding finally. My bad. Let us make our int as 3. So we are defining string source dist. So here we have to do n minus 1 string transfer. Now our source is source itself, but our helper is the destination, and our destination is helper. So yeah, I think it is clear to me. So let us just print also system dot out dot println transfer disk. Yeah. Now our source is the helper, and our source tower S tower is the helper, and our destination is the final one. And okay, so that's the same thing. And let us do our original naming, which is this can also work. Uh, let's run for one first. What is this? Ah, okay, okay. Anyways, let me ignore that. Yeah. Okay. Yeah. Okay. So transfer one disk from source to destination. Let us change this to 2. Okay. Transfer one disk from source to helper. Transfer 2 disk from source to destination, and then 1 from helper to destination. Yeah. Now let us finally run as 3. The naming is bit reverse, but I think it's fine. So this is not number of discs. It is a disc number, like first, second, third, and like that. Uh, so if we talk about time complexity, it is big O of 2 is to n minus 1, which is basically big O of 2 is to n. So there is definition going on for like what time complexity. Although we have not studied that chapter yet, I know a bit about it because I studied Python DSA in my for my college thing. It was terrible, but yeah, I think I at least know like basics of time complexity, and yeah, also. Okay, so yeah, that was about it for that. Uh, there are also some comments right here, so let me copy paste them only. Transfer top n minus 1 disk from source to helper using dest as helper. Source dest helper. Oh fuck, why is it giving me some bullshit right here? Transfer nth from source to dist. Yeah, that's good. And finally, uh, yep. So that is how it is done. Tower of Hanoi. 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 And yeah, we are finally done with recursion. Although not really, because we still need to practice, practice, practice. But anyways, that is it for today. I was going to do divide and conquer, but I think I don't want to bore you by making the video long and just staring at my screen watching the lectures. From tomorrow, I'll figure out something to do better on the streams, or if I don't, then you'll have to just bear with me doing this only. If you are watching, that is. But yeah, anyways, that is it for the day. I'll go do some other things, or maybe just sleep. Anyways, I don't know. If you're watching, have a good day or night. And yeah, that is it. Signing off. Bye bye.